skyscrapers, 7-star hotels, Palm Islands, and a global presence. These are probably what you think about when I say the United Arab Emirates, but a mission to Mars probably hasn't crossed your mind. In this video, we'll be discussing how the UAE planned and launched the first Arab space mission to Mars. Let's go. Founded in 2006, the Mohammed bin Rashid Space Center, known as MBRSC, is a governmental entity and is home to the UAE National Space Program. The space program includes space satellite projects, the UAE Astronaut Program, and the Emirates Mars mission. The center aims to raise awareness of the importance of science and technology for its UAE nationals, hoping they will be encouraged to indulge in such advanced fields and thus make the UAE one of the biggest players in the space industry, which is expected to grow to $2.7 trillion in 30 years, according to Merrill Lynch of Bank of America. But let's get into some specifics, starting with the satellite projects. So for starters, launched from Kazakhstan in 2009, Dubai Sat-1 was the first UAE Earth observational satellite. It helped at infrastructure development, urban planning, and environment monitoring and protection, built with the help of South Korea. The United Nations, for example, used Dubai Sat-1 images to monitor relief efforts following the 2011 earthquake and tsunami in Japan. Then, in 2013, the center launched Dubai Sat-2 from Russia, becoming the second satellite in orbit. It played a similar role but more advanced one than its predecessor, manufactured along with the South Korean partners again, but with notably more Emirati engineering influence. After that, in 2017, the center launched NaivSat from India in collaboration with the American University of Sharjah, which is the UAE's first nanosatellite launched into outer space. Naif-1's main objective is to send and receive messages on amateur radio frequencies. It can also be used for text messaging and other educational activities. 1 year later, in 2018, the center launched KhalifaSat, also known as Dubai Sat-3, from Japan. KhalifaSat was developed 100% in the UAE by a team of highly qualified Emirati engineers. So you can see what the UAE were doing. They were gradually improving their presence and role in these missions in terms of engineering, design, and influence. With 5 patents registered under KhalifaSat's name, it played a vital role in asserting the UAE's position amongst the leading space technology manufacturing countries in humanity's journey towards a future in space. Now we move on to the UAE Astronaut Program. Initiated in 2017, the program aims to prepare Emirati astronauts for scientific space exploration missions, creating a culture of scientific endeavor and motivating the youth to pursue space science, technology, engineering, and math, also known as STEM. In 2018, the first 2 Emirati astronauts, Hazza al-Mansouri and Sultan al-Niyadi, were handpicked from over 4,000 applicants. Al-Mansouri made history as the first Emirati to be deployed on a space mission to the International Space Station in 2019. During his mission aboard the ISS, he conducted 16 scientific experiments, 6 of which were conducted in microgravity, as in extremely low gravity presence where the body is not exactly weightless. His mission was 8 days long, where he landed safely afterwards. And now, the moment you've probably all been waiting for, the Emirates Mars mission. After countless alterations, inspections, and postponements due to the weather conditions in Japan's Tanegashima Space Center, the Hope probe finally launched into outer space in what is considered one of the toughest years economically and mentally in the world. It'll be the first probe to provide a complete picture of the Martian atmosphere and its layers when it reaches the red planet's orbit in 2021. It'll also help answer key questions of the history of the planet and whether it can be inhabitable in the near future or not. But what are the steps required for such a launch? Well, the spacecraft lies in the payload of the rocket, the thing that looks like a nose on top. The rocket launches and tilts slightly out of Earth's atmosphere. It then releases its boosters gradually where they fall back to Earth. The launcher would then separate from the spacecraft as the solar panels unfold so that the batteries start charging on the way to Mars. Now you might ask, are we just launching it so that it would roam freely in space? What if it gets lost? Don't worry about it. See, the spacecraft has a unique star tracking system. Yes, it uses the stars around it, just like our ancestors did, to locate where it is relative to Mars. There is no GPS system in space after all, so in a way, it'll know how to navigate itself by itself. And finally, it uses its thrusters to brake and slow down so that it aligns with the Martian orbit. Now imagine, if we send a signal for the thrusters to stop the probe, it would take 13 to 14 minutes for it to respond. Yes, that big of a delay because it is so far. So if anything goes wrong, the whole mission would fail. That's why the spacecraft will know what to do, hopefully, with its complicated system, because if things were to be controlled by Earth, it would be very risky. When it comes to the components of the probe, we can mention three main things. The infrared spectrometer that studies the lower atmosphere of Mars in infrared bands, the exploration imager that studies the lower atmosphere and visible and ultraviolet bands, in addition to capturing high-resolution images. And finally, the ultraviolet spectrometer that detects, as you might guess, ultraviolet wavelengths, which is important in detecting the abundance of CO2 and O2 in the Martian atmosphere. The reason their launch window was so small to begin with, which was between July and August, is because the Earth and Mars align their orbits once every 2 years, and this was the most suitable time for launch. They wanted to arrive by 2021 because it would be the UAE's 50th anniversary as well. Now you might think, why space? Why Mars? Why has everyone invested so much where all that money could be put into solving the problems here on Earth? China and US have already launched to Mars recently, and they have plans to launch many more satellites and rovers in the near future. But why? In short, as we examine the Martian planet more and more, in terms of the minerals on its surface, the once found water, and the serious climate change it has undergone, it can help us learn more about our home and maybe uncover details of the evolution and history of Earth and other planets in our solar system. Launching satellites into low-orbit Earth has always been a profitable venture for companies, but today, several companies in the US are looking very specifically at human spaceflight. Companies like SpaceX, Blue Origin, and Virgin Galactic have set their goals to reduce the cost of access to space, trying to consumerize the trip, where someday you might actually buy a ticket to take a tour around the Earth. The Mohammed bin Rashid Space Center ultimately is aiming to build a Mars settlement by 2117. Yes, that's pretty far ahead. They've already prepared a whopping 100-year plan for this implementation. Until then, the UAE plans to bolster its position in space exploration and enhance its national scientific capabilities. They want to inspire future Arab generations to make a difference, not just support that difference, but be part of it. And who knows, maybe one day we can actually retrieve essential elements and minerals that might prove valuable back on Earth and help improve the quality of life and the overall economy. So thank you guys for watching. What do you think? Will there be a day when we might actually live on planet Mars? Do you think the money we're investing in outer space is worth the effort? I'd love to know your thoughts on this in the comment section below. If you liked the video, please give it a thumbs up. Subscribe to the channel if you haven't, and turn on the bell icon so that you get notified when I upload new videos. And I'll see you in the next one.